Okay, so now we're going to be determining our linear model for this equation. So here you can see I've got my pictures and I've got my data. Now the important thing that I've got over here is that I have already split it up into what domain the linear model exists over. So the linear model exists between when t is equal to 0 up to where t is equal to 6. So I'm going to start by writing out that I am looking for a linear model or a polynomial. Okay, now if you're not doing a linear section and you're going to use your polynomial as being something with a higher power, then you can skip to the next video, okay, because you'll just need to fit your data in that case. So if we're looking for a linear model, that is in the form of y equals mx plus c. So I'm going to be picking two coordinates to find our gradient and our intercept. So therefore, the two coordinates that I'm going to use will be when time is equal to 0, subscriber count is equal to this, and my second coordinate is going to be, we'll use the end one. Now remember, you can state that it's any of them here, but this will make it fit to the start and to the end of that section. So when time is equal to 6, that is 55200. Okay, so to calculate our gradient, that is rise over run, or y2 minus y1 over x2 minus x1. So here we would have 55,200 minus 140,800 all over 6 minus 0. Okay, so equals. So let's go over here and we're going to go execute in our calculator. We're just going to punch this in. 55200 minus 1408 all over 6. Execute. So this is what it gives us as an exact. We're going to keep that in exact form. So 205600 over 3. And I'm doing that. Now, this is part of my justification. I'm keeping it in exact form so that I don't get rounding errors. Remember, as you're writing your assignment, you're thinking about the things you do and you just need to justify them. If you chose to round it, that's fine as well. You just need to state that you did that and why. So this is what we're going to be using as our gradient of the linear section. Now, the next thing that we're going to be calculating is the C value. So determine C. Now, you can use the 2-point method. You can also use that m equals the answer we got above and one of the coordinates. Okay, now we can chuck that into our formula. Equals now, when you multiply this by 0, you'll just get 0 for this whole thing, meaning that C is going to equal this. Okay, so therefore, the linear model for this equation is equal to y equals 205600 over 3 plus 140800. So now just to make sure, I'm going to double check by substituting this into Desmos. Now when I do that, I'm going to put in my domain as well so that it will graph nicely. So here you can see I've got my data in Desmos. We don't need to fit it. This is not a fitting assignment. So y equals 205600 divided by 3 x plus 140800. Let's just click back to the other screen. I should have written that down to start off with to double check. Yeah, okay, good. Okay, and now I'm going to put a domain in so that it doesn't go the whole way across. Now here I'm using X in my domain because that's what it's got labelled as for time in here. But really, I am thinking about this in terms of T. If I want to change it so it's in terms of T, all I have to do is change this one here to a T, change this to a T, and change that above to a T. Now, just remembering where these little brackets go for my piecewise functions. Nope, not there. Interesting. Maybe I do have to fit this. Nope. Okay, so I've done some magic editing here. So all I needed to do was move the domain that we were going to be graphing it over to the front, put those little double dots in, and then write in the function type that we've decided on. So that's what I've done to get this function here, and you can see the blue line is appearing over the top of those. So it's showing me how this will look for my function. And that's all we needed to do for our first linear section.